Okay, ladies and gentlemen, this lecture will cover severe weather, including tornadoes, hurricanes, and the formation of hail. We'll start with tornadoes. In order for a tornado to form, you need several things to happen in the atmosphere. First, you need warm, moist air at the surface. We generally get that from the Gulf of Mexico. That will move to the north. You need cold, dry air aloft, that is A-L-O-F-T, that means high above or up. So you need cold, dry air at higher altitudes. And when you get this mixing occurring, you also get spin in the atmosphere, and with everything is situated correctly in the atmosphere, you can get a tornado to form. So, again, you need warm, moist air to the surface, cold air aloft. That gets you to the development of cumulonimbus clouds and supercell thunderstorms, which are just very large, rotating thunderstorms. Typical cumulonimbus cloud is shaped like this, like an anvil. You have the overshooting top right here. You have the anvil spread out. On this one, it's about, 38,000 feet. The direction of movement is from left to right in this picture. These are cirrus clouds. Mammatus clouds would be sort of right there. The leading edge of a cumulonimbus cloud will occasionally have what's called a gust front, something that looks like this, and I have another picture that will show that. The rain is always in the front of the storm. Rain is right there. This is in the downdraft parts of the thunderstorm. Rain, any kind of precipitation falling out of the thunderstorm, is typically in the front of the thunderstorm. The tornado is typically in the rear of the thunderstorm, where you have the updraft, that is rising air, downdraft is sinking air. A tornado pulls in air from the surrounding environment. Cumulonimbus clouds can range, say in this picture, from like 40,000 feet. I've seen them as high as 80,000 feet. This one is just showing you the what a gust front would look like. This is actually kind of backwards. Disregard that. That's wrong. And the rain is actually on the wrong side. But anyway, as air rushes out of the thunderstorm, it can lead out ahead of the thunderstorm. You get these gust fronts, which can be very fast-moving, horizontally moving air, can cause damage before the main thunderstorm arrives. This picture is really showing you how hail forms. Hail is frozen precipitation. It is not sleet. It is not the same as sleet. Hail forms when you have a raindrop that will condense on a dust particle. That dust particle and that raindrop then gets caught up in the updraft and rises. It gets very cold and freezes in the upper part of the cumulonimbus cloud. It falls down through the downdraft. As it falls, it will coalesce, get bigger, collecting more water. It will get caught back up in the updraft, rise upward, freeze again, fall down in the downdraft and melt a little bit, get bigger, and so on and so forth, until it gets so big that the updraft cannot hold it in the thunderstorm, and we get hail. This picture shows a fairly large hailstone. The arrows on this image are pointing out all the layers of the hailstone. The layers can tell you how many times the hail went up and down the thunderstorm, almost like counting the rings on a tree. The larger the hailstone, the stronger the updraft, and typically the stronger the thunderstorm. So tornadoes, again, this is a supercell thunderstorm. This is not my picture. The gust front is, you can actually see it, it is right here. It's the leading edge of a supercell thunderstorm. You get very, very strong straight line winds. Straight line meaning moving horizontally in one direction. They're not spinning. So, for the first thing that forms with a tornado is a wall cloud. You have this this cloud that just drops down out of the thunderstorm. It is rotating and is pulling air. Is pulling air upwards. The next thing is a funnel cloud, which on here is right there. A funnel cloud is a typically cone-shaped. It is a rotating, very small rotating column of air that's extending out of the wall cloud. Once you start seeing debris or dust fly up, that means the tornado is on the ground, causing damage, and the National Weather Service can officially report a tornado is on the ground. This picture will instigate a tornado warning, which is a tornado is actually happening. Tornadoes suck. They suck air in. The funnel does not always need to be touching the ground. Here's the first arrow there is the actual condensation funnel. The debris is part of the tornado. This can be dust, it could be cars, houses, animals, whatever. There are tons and tons of video out there of tornadoes hitting houses, businesses, neighborhoods, fields like this one. There's lots of videos out there showing you what not to do, which is getting under an overpass and whatnot. For severe storms, there is one thing that you guys need to know. There are 3 things the National Weather Service looks for when issuing a severe thunderstorm warning. One of them is the presence of a tornado. 2 is winds at greater than or equal to 50 knots. That's roughly 57 miles per hour, I believe. Or you have hail 3/4 inch or greater. Notice lightning is not a factor in this. Also notice the amount of rain is not a factor in this. These are the only 3 conditions that will warrant a severe thunderstorm warning. That means it is happening, you need to take cover. A watch indicates the conditions are favorable for a severe thunderstorm to occur. For a tornado warning, you need either, this is for a tornado warning, either you need a visual confirmation of a tornado. There are only certain people who can officially report a tornado, that is any kind of emergency personnel or a trained Skywarn spotter or any kind of trained spotter or storm chaser. Those are the only people that can really officially report a tornado. Or the Doppler radar can indicate a tornado. A Doppler radar can see rain and other stuff swirling around a location, and that could generally get you a tornado. The tornadoes are rated on what's known, this is actually not the Fujita scale anymore, it's the enhanced Fujita scale. They updated this a few years ago. It is a scale based on damage. It is not really accurate for tornadoes that occur over farmland, but that's what the enhanced scale does that. In the old scale, in the old Fujita scale, you could theoretically have confirmed winds of 250 miles per hour over farmland, but since it didn't cause much damage, could be rated as an F1 or even an F0. They are now called EF0s, EF1s, EF2s, and so on and so forth. The Raleigh tornado that we had 4 years ago was rated an EF3 with winds on this scale upwards of 200 miles per hour. Let's move on to hurricanes. Hurricanes are very large areas of low pressure. They rotate counterclockwise. There is a central area of high pressure, and we know from before hurricane season starts in June and peaks in September and ends in November. Parts of a hurricane. First off, a hurricane needs warm ocean water. More than 80 degrees Fahrenheit. That's in the tropics, obviously. This is the fuel for a hurricane. The ocean water causes more evaporation, creating humidity. Convection can occur. We get a lot of clouds to form. Winds coming together at the surface, moving upward. That's that area of low pressure. So the actual surface the surface low pressure is right here. Winds are being pulled into it and up into the storm. Winds will flow outward at the top, allowing more air to rise below, just like our convection demo last week. You need humid air, makes that convection to occur, and when that convection occurs, you get clouds to form. You need winds outside of the hurricane to steer it along and move it either over land or wherever it needs to go. So you have this very center part of the storm, you have a very centralized high pressure, that's sinking air, that's where the eye of the storm comes from. Winds will weaken with height, and that is a spiral outward and clockwise. At higher altitudes, the warm humid air spirals inward at the center and on the surface, allowing the storm to grow and grow and grow. Please note the maximum winds are found in the eye wall. That's the most dangerous part of the storm. The eye wall is the eye is the most calm part of the storm. This is Hurricane Katrina. Very pronounced eye. This is right now. It's in this picture. It's an F5. It's a Category 5 hurricane. It weakened just before making landfall, and then hitting New Orleans and on the coast of Alabama. There is a sides to these hurricanes that are weaker and stronger. As this whole thing is spinning counterclockwise and moving to the north, the strong side is the right side, specifically the right front quadrant. Let me just make this a little bit bigger. You got this area here is the right front quadrant. It's the strongest part of the storm, because not only do you have the momentum of the storm moving to the north, you also have the winds coming from the south too. The weak side, the left rear quadrant over here, this is the weakest part of the storm. The momentum of the storm moving to the north is counteracted by the northerly moving the northern winds on the left side of a hurricane. If you have to be in a hurricane, you want to be on the left side of the track. The right side, you'll get the most damage. New Orleans was spared the brunt of it. Mobile, Alabama, on the coast of Mississippi got the worst of the storm. Storm surge is any water pushed ashore by the winds of a hurricane. Literally in the central area of the storm, that the pressure is so low that the wind is pulled upward. It's worse, obviously, when you have a full moon, when the tides are the greatest. Storm surge is the most common reason for damage and loss of life. It causes more damage and loss of life than the winds of a hurricane. If you live on the beach, you need to evacuate. You also will want to protect your home, too. Stages of a hurricane. You have a tropical depression that's typically labeled as an L on a weather map. Just a disorganized area of low pressure in the tropics. Tropical storm is organized. Winds are sustained, meaning constantly blowing at 39 miles per hour. You have a circle with that kind of symbol. And a hurricane is winds of 74 miles per hour with a symbol that looks like that, colored in. Saffir-Simpson scale is how we rate hurricanes. Category 1, winds upwards of 95 miles per hour. Category 5, hurricanes greater than 155 miles per hour. You do not need to know anything about the storm surge or pressure. Those can vary greatly. The strongest hurricanes on record, like Hurricane Andrew, Hurricane Hugo, Fran, Floyd, Hurricane Hazel, Camille, were all Category 4s and 5s, causing billions of dollars in damage. That's all we got for tornadoes and hurricanes. If you have any questions, let me know. And we'll see you next time.